Hello everyone, welcome to the Learning Cubicle. In the previous class, we have learnt about one of the motion graphs, that is acceleration time graph. And today we will be learning about motion equations. Now what are motion equations? These are those equations which give the relation between various quantities that we have discussed throughout this lesson. That is velocity, acceleration, time, displacement, and many other things. So we will discuss the derivation of these motion equations. Means how do we obtain these motion equations, right? And that can be done in two different ways. One way is deriving them graphically, as you can see here, and the other one is a non-graphical derivation of these motion equations. Now first let us discuss what are those motion equations. We have three motion equations over here primarily. The first one is V is equal to U plus AT, and the second one is S is equal to UT plus half AT square, and the third one is V square minus U square is equal to 2AS. So we have these three motion equations. V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. You can actually identify some of the variables over here. S is displacement, you know that. A is acceleration, you know that. And T is time. Now what are these V and U? U is basically the initial velocity and V is basically the final velocity. So these are the terms we have: initial velocity, final velocity, acceleration, time, displacement. These are the quantities which are involved in these three motion equations. And these three motion equations give the relation between these quantities. You can see different motion equations over here. Now, coming to the derivation of these motion equations, let us see how to derive the first one. The first motion equation, V is equal to U plus AT, and for deriving these motion equations graphically, we use the velocity time graph. Now you might be thinking we have three motion graphs. One is displacement time graph, two is velocity time graph, and three is acceleration time graph. Now out of these three, why is that we are only choosing velocity time graph? Why not the other two, any of the other two? The reason is that from this velocity time graph, you can obtain all the quantities what we discussed just now. We can obtain initial velocity, we can obtain final velocity, time, acceleration, which is the slope of this graph, and displacement, which is the area under the graph. So every other quantity what we have in those equations can be obtained from this velocity time graph, which is not possible in case of displacement time graph or acceleration time graph, because displacement time graph doesn't give acceleration and acceleration time graph doesn't give you displacement. So that is the reason why we choose this. Okay, now coming to the derivation of the first motion equation, which is V is equal to U plus AT. Now for that we need to consider a body which is moving with an initial velocity U, which is already having some initial velocity, which is U. Okay, and it picks up a final velocity which is V, and that's the reason why the graph has gone like this. Okay, so initial velocity of the graph of the body and the final velocity of the body over here. So this is the graph. So we need to derive this equation from this graph, right? So U you can see in the graph, V you can see in the graph, T you can see in the graph, but only thing that you cannot see over here is acceleration. So we have to obtain that. So we already learnt how to obtain acceleration from velocity time graph. That is nothing but slope of the graph. We learned that, right? So slope of the graph is equal to, right? Now let us see what is that over here. We learned that difference of y coordinates by difference of x coordinates is what the slope of the graph is. We learned that already, right? Now the graph starts over here and ends over there. So the y-axis portion is nothing but this, you can see. This is the y-axis portion. Okay, so let us try to find out what that is from the graph. We have here 0 to u, so this is u, this part is u. So obviously this part also will be u because opposite sides of this rectangle. Now the y-axis part is this. We want this, we still didn't get that. But if you see, this part is v, up to here it is v, means this whole thing is v. See, this whole thing is v. So this whole thing, what you have here is v, because that corresponds to this. Okay, now this whole thing is v and this thing is u. So this small portion over here will be v minus u. I think you agree with me, right? This whole thing is v, this small thing is u. So this small portion over here is nothing but the total minus this, which is v minus u. So difference of y coordinates is v minus u by difference of x coordinates. X coordinate is starting over here and ending over here, which is 0 to t. So this distance is nothing but t. Okay, and we know slope of velocity time graph is nothing but acceleration is equal to v minus u by t. Now do the cross multiplication. We will get v minus u is equal to a times t. So if send the minus u that side, this is the first motion equation. V is equal to u plus at. So that's how we can obtain the first motion equation graphically, right? Now let us try to derive the second motion equation. The second motion equation, as already discussed, s is equal to ut plus half at square, right? Now u you can see in the graph, t you can see in the graph, a we can't see, but we cannot try to find out a, because if we try to find out a, we will end up getting the same first motion equation again. So we need to get displacement, and displacement is not there in the graph anywhere, but we can get it by finding the area under the graph. So area under the graph is equal to, now this is the graph, this is the graph, and under the graph this is what you have. This whole thing, all these blue lines what you can see, that is what under the graph is, not the above the graph, area under the graph. So under the graph you have one rectangle very clearly seen over here, and one right angle triangle is what you can see here. This is a right angle triangle. Okay, now let us suppose this as figure 1 and let us suppose this as figure 2. Okay, so area under the graph, I can write it as area of figure 1 plus figure 2. This is area under the graph. But for velocity time graph, area under the graph is nothing but displacement, I told you already. Now area of figure 1. Figure 1 is a rectangle, and rectangle area is length times breadth. Length is t, breadth is u. So t times u. alright, plus area of figure 2. Figure 2 is a right angle triangle, and right angle triangle area is half multiplied by the base. Base is this. This is nothing but t. You can see here. Multiplied by height. Height is this from here till here, which is nothing but v minus u. Right? So S is equal to, this is ut plus half t v minus u. From the first motion equation, if you see, we have the first motion equation as v is equal to u plus at. So if you bring u this side, it will be v minus u, so it will be at. So v minus u is equal to at from the first motion equation. So instead of this v minus u, I am going to write at over here. So S is equal to ut plus half at times t, which is at square. That's the second motion equation. Am I clear with that? So this is how you obtain or derive the second motion equation. Right? Thank you.